In this video, we will discuss different types of optimization problems: continuous, discrete, linear, and non-linear problems. As we already discussed in previous video, we can classify optimization problems based on the type of constraints, nature of design variables, problem's physical structure, nature of equation, and number of objective functions. In this video, we will discuss different types of optimization problems. Here you can see two types of optimization problems: convex optimization problems and non-convex optimization problems. We will discuss non-convex optimization problems. Non-convex optimization problems are further classified as continuous optimization and discrete optimization that we will discuss in detail in the upcoming slides. Here you can see continuous optimization problems are further classified as constrained optimization and unconstrained optimization problems, and discrete optimization problems are also further classified as integer programming, network optimization, and other. Here you can see different examples for discrete and continuous optimization problems. Discrete optimization problems such as graph theory, knapsack problem, integer linear programming problem, traveling salesman problem, and continuous optimization problems such as convex programming, linear programming, non-linear programming, and quadratic programming. First, we will discuss discrete optimization problems. Discrete optimization problems mostly deal with the issues where we need to select the best solution from a finite number of solutions. We can express discrete optimization problem as minimize function fx subject to constraints. Here x, that is a finite set, but it is largely sufficient to examine every feasible solution. In the discrete optimization problems, we have finite set and we need to choose the best solution from the finite number of solutions. In discrete optimization problems, variables are restricted to 1 or 0. Here you can see one discrete optimization problem, that is 8 puzzle problem. In 8 puzzle problem, our goal is to move from a given initial position to final position in minimum number of moves. This is the initial position, and here this is the goal position, and we can move up, down, left, right. And in 8 puzzle problem, you can see here we have 3 by 3 grid with 8 square blocks, 1 to 8, and we have one blank block. We have to rearrange the blocks 1 to 8 in order, and you can see this is the final position. So we have to arrange the blocks from 1 to 8 in order: 1 2 3 4 5 6 7 8. Now let's try to solve this problem. So here you can see this is the initial position. We can move with the 1 2 3. So first we will move 2 up, next we can move 5, next 6, next it is done. So here you can see we have initial stage and this is the goal stage, and you can see number of steps that we use to solve this problem. So our aim is here to solve this puzzle in minimum number of moves. In each step optimization problem, function is defined, that is fx equal to gx plus hx. Here gx defines initial state or how many steps in problem you have completed so far. hx define number of ways from current stage to goal stage. So this is the discrete optimization problem. We need to select the best solution from the finite number of solutions. Next we have continuous optimization problems. Continuous optimization means find out the minimum or maximum optimal value of a function which subject to different constraints, and here we have one or more real life design variables. So here optimization problem objective is to find set of variables that achieve best solution results for any objective function. And here you can see we have a set M that is infinite. It means we have infinite solutions. So we have to find out set of variables that achieve best possible results for any objective function. Iterative algorithms are used to solve continuous optimization problems, which iterates a sequence of values to a solution to the problem and converges to a solution. Such algorithms use information learned from past iteration when selecting how to move from one iteration to next. Here you can see we have different types of continuous optimization problems: linear, nonlinear, constrained, unconstrained, conic, quadratic, convex, and other. Next we have linear programming. Linear programming problems are simple and easier to solve than nonlinear programming problems. In linear optimization problems we have both objective function and constraints. Linear and constrained equation may be in form of equalities or inequalities, and here all the decision variables are non-negative. This is the standard form for linear problem. So we can express linear problem using this standard form: minimize function fx with subject to constraint, and here we have the design variable. This objective function contains linear equality and inequality constraints and design variables. Suppose we want to minimize the cost. So here you can see this is the constraint and this is the objective function, and we have two control variables. Linear programming consists of design variables, objective function, constraints, and non-negative restrictions. First we have design variables xy. It decides the output of the linear programming problem and it represents the final solution. Next we have the objective function, that is a linear objective function that we will optimize to get the optimal solution. Next we have constraints. Constraints are like restrictions imposed on the design variables to limit their values. Next you can see here design variables must have non-negative values. Now here you can see this is a linear programming problem. Suppose a parcel delivery boy has to deliver 6 parcels in a day from this store to 6 different houses, and you can see the distance between the houses is indicated by the lines, and you can see the weight on the lines like the distance between houses. So this delivery person want to find out the shortest route to deliver parcel and save fuel. This is a linear programming problem, as the delivery person want to find out the shortest route to deliver parcel and save fuel. So how we can solve linear optimization problems? Here you can see steps to solve linear optimization problems. First, identify the design variables. Next, formulate the objective function. Check if the function need to be minimized or maximized. Next we have constraints. Note down the constraints. Next we will check if the design variables have non-negative restrictions. Next we will apply the method, either simplex or graphical method, to solve linear programming problem. So this is the simple process that we can use to solve linear optimization problems. For example, here you can see this is the delivery person. He want to deliver parcel to 6 different houses and he want to find out the shortest route and save the fuel. Next we have non-linear problem. We can express nonlinear problem as minimize any function fx which subject to different constraints, and here we have different equality and inequality constraints that we will discuss in detail in upcoming videos. So in this video we discuss continuous optimization, discrete optimization, linear programming and non-linear programming. In discrete optimization problems we have a finite set and we have to select the best solution from finite number of solutions, and this is the discrete optimization problem example where we have to solve 8 puzzle problem. Next we have the continuous optimization problem where we have infinite number of solutions and we have different constraints and more real life design variables. Next we have linear programming problem that is easier to solve as comparison with non-linear optimization problems. Here the objective function and constraints both are linear. In next video we will try to understand non-linear problems in detail. So that's all about this video. If you have any questions you can comment below, and thanks for watching this video.